Right now, at the very heart of our own galaxy, a monster we thought was sleeping is starting to stir. For years, the supermassive black hole Sagittarius A** has been a relatively quiet giant at the center of our cosmic home. But our latest observations show it's got a ferocious and surprisingly constant appetite. The story of this cosmic hunger is rewriting everything we thought we knew about the forces that shape our galaxy. So what's causing this change? And what does it mean for the future of the Milky Way? Stick around, because the answers are going to take us to the very edge of what we know about space, time, and existence itself. Now, scientists are racing to figure out what or who is on the menu. This isn't science fiction. This is real, and it's happening 27,000 light-years away. The galactic anchor. Before we get into the mystery of its growing appetite, let's be clear about what we're dealing with. Deep in the core of the Milky Way, in the direction of the Sagittarius constellation, there's an object of almost unimaginable power. Sagittarius A, or SGRA for short. It's a supermassive black hole, a gravitational titan with a mass of 4.3 million suns, all crammed into a space so dense that absolutely nothing, not even light, can escape. Every single star, planet, and nebula in the Milky Way, including us, is locked in a cosmic dance, orbiting this one central point. You can think of it as the sun of our galaxy, but instead of giving us light and heat, it provides the gravitational glue that holds everything together. For billions of years, SGRA* has been the silent anchor of our galaxy, especially when you compare it to the raging monsters at the centers of other galaxies. Quasars are famous for furiously eating matter and blasting out colossal jets of energy. Our black hole, on the other hand, seemed to be on a strict diet, just occasionally sipping on little bits of gas and dust that wandered too close. This quietness made it incredibly hard to study. We can't see the black hole itself. We can only tell it's there by watching the frantic orbits of stars caught in its pull. Like the star S2, which whips around SGRA* at millions of miles per hour. For most of the time we've been watching, SGRA* has been what astronomers call quiescent or quiescent. So for decades, the story of SGRA* was about relative peace, a sleeping giant whose power was mostly potential. But that story is changing. The giant is stirring, and the faint flickers of its activity are sending ripples through the entire astronomical community. The mystery of the flares. The first clues that something was up came in the form of light brilliant, high-energy flares of X-rays erupting from the black hole's neighborhood with surprising frequency. SGRA* has always had the occasional hiccup, but astronomers using telescopes like NASA's Chandra X-ray Observatory noticed the pattern was changing. It turns out, SGRA* is never really quiet. It's constantly bubbling with activity. Scientists have seen a continuous stream of flares, from faint, seconds-long flickers to blindingly bright eruptions that happen multiple times a day. We're now seeing about 5 or 6 significant flares daily, with countless smaller ones in between. Imagine a chaotic, non-stop fireworks show at the center of our galaxy, and with our newer, more powerful tools, like the James Webb Space Telescope, the picture has become even wilder. This sustained activity raises a huge question. Black holes don't just turn on for no reason. Their activity is tied directly to what they eat. More flares mean more feeding. It's like seeing smoke pouring from a volcano you thought was dormant. Something is bubbling up from below. SGRA* is eating more, or at least it's eating more mess. And the evidence is being broadcast across the cosmos in these bursts of intense radiation. The supposedly quiet giant at the center of our galaxy is getting a lot louder, and scientists around the world are leaning in to figure out what disturbed it. The investigation and the tools of the trade. So, how in the world do you investigate a cosmic mystery happening 152 quadrillion miles away, around an object that's literally invisible? Well, you build some of the most sophisticated instruments humanity has ever dreamed of. The first big breakthrough came from a global project called the Event Horizon Telescope, or EA. This isn't just one telescope. It's a network of radio telescopes scattered across the planet, from Hawaii to the South Pole to Spain. By linking them all together, the EHT creates a virtual telescope the size of Earth itself. The EHT has since looked at SGRA* in a special kind of polarized light, which lets astronomers map the magnetic fields wrapped around the black hole. And what they found was stunning. The magnetic fields at the edge of SGRA* aren't a chaotic mess. They're strong, twisted. NASA's Chandra Observatory is the one that spots those high-energy giving us a minute-by-minute activity log. And the James Webb Space Telescope, with its unmatched infrared vision, is peering right through the thick dust of the galactic center, watching the chaotic dance of matter as it gets pulled in. By putting all the data together, we're going from a static photo to a dynamic, multi-wavelength movie of our black hole, watching it breathe, flare, and most importantly, and incredibly organized, spiraling around the event horizon. This was a massive revelation because powerful, ordered magnetic fields like these are the engines that can drive a black hole's most dramatic events. This insane resolution is what allowed astronomers to finally do the impossible. In 2022, they took the first ever direct image of Sagittarius A*. The picture didn't show the black hole, of course, but its shadow, dark center silhouetted against a swirling, glowing ring of superheated gas. This was the point of no return, made visible. But seeing the silhouette was just the start. Alongside the EHT, other titans of astronomy are on the case. The culprits. What's on the menu? With all our best telescopes pointed at the galactic center, the big question is still, what is SGRA* actually eating to cause this light show? The answer probably isn't one giant meal, but a buffet of cosmic snacks. The area around a supermassive black hole is a chaotic and crowded neighborhood, full of stars, gas clouds, and dust. Most of this stuff stays in a safe orbit, but every now and then, something gets knocked off its path and wanders a little too close. Back in 2012, astronomers tracked an object called G2 as it flew right by the black hole. People were expecting a huge fireworks show, but G2 mostly survived. Still, some astronomers think it's no coincidence that the bright X-ray flares started picking up just 6 months later. It is possible that the tail of gas trailing behind G2 got stripped away and is now being slowly devoured by the black hole, causing it to burp these flares. One leading idea for the increased flaring involves gas clouds. When a star gets too close, the black hole's gravity rips it apart in what is called a tidal disruption event. The star's material gets stretched into a long strand of spaghetti. Some of it gets flung back into space, but the rest settles into orbit, providing a steady food source for thousands of years. The current flares could be caused by clumps of this old shredded star finally falling past the event horizon. Another possibility is that we're seeing the leftovers of a star that was torn apart long ago. Black holes are messy eaters. The flares seem to be coming from the black hole's inner accretion disk, very close to the edge. Some scientists now think the flares are caused by something called magnetic recombination. This happens when the powerful, tangled magnetic field lines in the disk suddenly snap and reconfigure, releasing a tremendous blast of energy. It's like a solar flare on our sun, but cranked up to an almost unimaginable scale. So it might not be a single thing being eaten, but the wild physics of the superheated plasma itself that's generating this constant, bubbling activity. But the latest discoveries from the James Webb Telescope suggest the answer might be even more complex. We are literally watching the engine of our galaxy in action, a spectacle of physics at its most extreme. Figuring this stuff out is what drives modern astronomy. If you're finding this trip to the heart of the Milky Way as amazing as I do, maybe hit that subscribe button and ring the notification bell. We tackle the biggest questions in the universe every single week, and you won't want to miss what's coming up. Now, let's get back to the bizarre physics of Sagittarius A*. The deeper physics of furious spin, so what's on the menu is one part of the story. But how a black hole eats is just as important as what it eats. And two recent discoveries have added a wild new layer to SGRA*, its powerful magnetic fields and its incredibly fast spin. As we mentioned, the Event Horizon Telescope found strong, organized magnetic fields spiraling around the black hole's edge. This was a game changer because these fields look shockingly similar to the ones around M87*, a black hole that is 1,000 times bigger and powers a jet of plasma that blasts across its entire galaxy. The fact that they look so similar suggests that SGRA* might have a hidden, dormant jet of its own just waiting for a reason to switch on. Why do these magnetic fields matter so much? They act like cosmic slingshots. As gas and dust swirl into the black hole, these field lines get twisted up like a rubber band. A fast spin and strong magnetic fields are the two key ingredients for a hyperactive black hole. Our SGRA* has both. All it's missing is a big, steady meal, and these recent flares suggest its food supply might be getting more consistent. If a large enough gas cloud or an unlucky star gets too close, that new fuel, combined with the magnetic fields and the rapid spin, could awaken the true monster within. This process can launch particles out into space at nearly the speed of light, creating powerful jets. Right now our black hole's jet seems to be off, or at least very weak. but the machinery is there. If enough fuel falls in, that engine could roar to life. And adding to this volatile mix is the black hole's spin. Scientists recently measured how fast SGRA* is rotating, and the result is just breathtaking. It's spinning at about 60% of the maximum speed allowed by the laws of physics. According to Einstein's theory of general relativity, this spin is so powerful that it literally drags the fabric of space-time around with it. The space around SGRA* isn't a sphere. It's squashed into a shape like a football. This incredible spin is another huge source of energy. A black hole's rotational energy can be tapped by those magnetic fields to power jets and outflows. The why it matters. Galactic implications at this point. You might be thinking, this is cool and all, but does a hungry black hole 27,000 light-years away really matter to me? And the answer is a huge yes. The behavior of SGRA* has massive implications for how our entire galaxy evolves, and it helps us understand our place in it. Even if it fired up a powerful jet, it would have to be aimed almost perfectly at us to have any effect, and there's no sign of that. We're safely tucked away in a quiet, suburban spiral arm of the Milky Way, far from the chaotic downtown core. The energy blasted out by a supermassive black hole, even a relatively quiet one, can affect star formation across the galaxy. These outflows can push gas out of the galactic center, stopping it from collapsing to form new stars. Or, the shockwaves can compress gas clouds somewhere else, triggering a burst of new stars. The Fermi bubbles too, giant bubbles of gas, extending above and below our galaxy, are thought to be the leftovers from a massive eruption from ** millions of years ago. In a way, the black hole acts as a galactic thermostat, regulating the birth of stars. First, let's get the big question out of the way. Are we in any danger? The short answer is no. SGRA* is incredibly far away. It lets us test our ideas about how black holes grow, how they eat, and how they evolve with their galaxies. SGRA* is our personal cosmic laboratory for understanding the fundamental forces that built the universe. Its hunger is a clue not just to its own nature, but to the nature of the cosmos itself. But the activity of SGRA* absolutely matters on a galactic scale. Studying our own black hole gives us a front-row seat to the processes that might be raging in distant, more active galaxies. The cosmic future, the story of Sagittarius A*, doesn't stop with its current snack time. On cosmic timescales, much bigger things are on the horizon. The drama we were seeing now is just a tiny prelude to a galaxy-shattering finale that will unfold over billions of years, rushing toward each other at about 110 kilometers per second. The two galaxies are set to collide in about 4.5 billion years. The stars are so far apart that very few, if any, will actually hit each other. Instead, it will be a gravitational war. The two majestic spirals will pass through each other, pulling and stretching one another into new, bizarre shapes. After a few 100 million years of this cosmic dance, they'll merge into a single, giant elliptical galaxy, which some astronomers are already calling Milky Way. You see, our galaxy isn't alone. We're on a direct collision course with our biggest neighbor, the Andromeda Galaxy. Now, this won't be a crash in the way we think of it. And at the heart of this new megagalaxy will be two supermassive black holes. Our SGRA* and Andromeda which is much bigger. These two giants will start their own slow, deadly dance, spiraling closer and closer, radiating enormous amounts of energy as gravitational waves ripples in space-time itself. The final merger of these two black holes will be one of the most violent events our corner of the universe has ever seen. The new, combined black hole will be a true behemoth. All the gas and dust funneled towards it during the galactic collision could ignite an unbelievably powerful quasar, creating an active galactic nucleus more brilliant than anything the Milky Way has ever produced. That is the ultimate destiny of our galactic core. A quiet giant, waking for a snack today, destined for a cataclysmic merger that will reshape our cosmic neighborhood forever. So, what have we learned on this trip to the heart of the Milky Way? We've seen that our supermassive black hole, Sagittarius A*, is anything but a boring, dormant object. It's an active, dynamic engine, constantly bubbling with flares and showing signs of a growing hunger. These discoveries aren't just about our black hole. They're a window into how all galaxies work, showing us how these gravitational monsters shape their homes. Thanks to incredible tools like the Event Horizon Telescope and the James Webb Space Telescope, we're not just guessing anymore. We are watching it happen. It's a tale of a deepening mystery, mind-blowing technology, and our relentless need to understand the universe. The monster at the center of our galaxy might be getting hungrier, but for scientists, that just makes it all the more thrilling to watch. What secrets will it give up next? We've learned that its flaring is likely fueled by stray gas clouds and the wild physics of its own superheated disk, all supercharged by powerful magnetic fields and a dizzying spin. The story of Sagittarius A** is a perfect example of what makes science so exciting. Thanks for joining me on this exploration of our galaxy's hungry heart. If you want to keep up with the latest discoveries from the front lines of space, make sure you're subscribed. Drop a comment below and let me know what you think is causing all this new activity. Until next time, stay curious.